Our topic is improving recommendation system by rating score prediction models with Yelp challenge data. A recommendation system is one kind of information filtering system which is used in boosting commercial sales. Here we list the four popular models in recommendation system. Inside of them, we pick the matrix factorization model and deep learning model for in our project. Let's have a look at the dataset. The Yelp dataset has all files in JSON format. We choose the subset of states Arizona, which is the best review dataset we can obtain. We extract the 7 features from the business JSON and review JSON, and how we did is shown in the diagram. The dataset after the pre-processing is shown below. So the first model we built is a probabilistic matrix factorization model. First, we create user restaurant rating matrix. The N rows represent N users, M column represents restaurants, and the entry RIG represents the IC users rating on the G's restaurant. Our target is to know the unknown, the missing ratings in the matrix. We can model the problem as R equal to U dot multiply way, where U is the latent feature matrix for the users and V is the latent feature matrix for the restaurants. And we use a probabilistic method to learn U and V from existing rates. The entry RIG is determined by normal distribution of UI dot multiply VG. Then we can get the conditional probability of R given UV. In order to maximize posterior, we maximize the objective function to obtain the ideal parameters. In practice, we use the stochastic descent to update stochastic gradient descent to update the UI and VG. We use RMSE and precision and record accuracy at top K to evaluate model. The best RMSE on train is 0.86 and on test is 1.45. The precision accuracy at top 30 is 0.66 and record accuracy is 0.65.
Our second model is CNN autoencoder. For this model, we predict each user's rating based on their reviews, cities, and categories of each restaurant. For data preparing and the beginning, we remove the punctuation, stop word, and remove other related noise. For each users and each restaurant, we build a vocabulary to include keywords with rating 1, 2, 3, 4, 5. For keyword, we just include noun, adjective, and verb. Finally, we build a matrix based on the frequency of the word and normalize the frequency. So finally, our input for this model is the frequency matrix of tests for each restaurant and each user, and output is the rating of the restaurant. The main steps in our model is that at the beginning we use 8 convolutional layers to learn the features of the data. Then we use plenty layers to flex data to a single column. Finally, we use 3 density layers to do the downsampling. The best accuracy in our model is 0.9. The picture is in the right. You can see the accuracy of our model. Thank you.